What's up, algebra? Today we are doing lesson 7.2, which is multiplying powers that have the same base. Okay, so we're just going to go ahead and jump into it. Okay, so we're going to scroll down, or I'm going to scroll down, I guess, to page 426. All right, we're just going to start out by looking at problem 1. Okay, problem 1 is a good example of the basics of what we're looking at with this lesson. Okay. So it gives us 12 to the 4th power times 12 to the 3rd power. Okay. Now, if I write these out, which I'm going to do right here, you're going to end up getting, and I'm going to group them with parentheses. So I have 12 times 12 times 12 times 12. Okay, that's 12 to the 4th power right here. And then I'm going to multiply the other one, which is 12 times 12 times 12. Okay, that's our 12 to the 3rd power. All right, now I can go ahead and get rid of the parentheses since every single step here is multiplication. It's not going to make any difference. Okay, I've got 1, 2, 3, 4, 5, 6, and 7. Okay, so if I go ahead and simplify that, that's going to give us 12 to the 7th power. All right, and that's it. Okay, now you'll notice if I look at these two next to each other, okay, really all I have to do for these is add our exponents, right? Because if I do 12 to the 4th times the 3rd, that's going to give me 12 to the 7th. Okay, now it's important if you try to do this, okay, this is what you want to be doing. Okay, but it's important that we have the same base for both of them. It only works if if both numbers have the base of 12 or the base of 3, or they just have to have the same base, right? If we try to do it with 12 to the 3rd power times 4 to the 2nd power, okay, we don't know what to put here. Okay, so we can't do that one. All right, so make sure they have the same base, and then we can use this little trick. Okay, so once you've understood that, we're going to go ahead. I'm going to have you guys do got it problems A, and got it problem B as well. Okay, so go ahead and try those two out, and then we will go ahead and move on after that. Okay, so problem 2, this is where it gets a little bit more interesting. All right, so this is where you've got to really focus and be careful on problems, okay, because this is where you can kind of trip yourself up a little bit. So if we have 4z to the 5th times 9z to the negative 12th, okay, that's just got it, or that's just problem A here. Okay, if we're going to solve this, it's important that we note what the exponent is attached to. Okay, on this one it's attached to the z, on the second one it's also attached to the z. Okay, it is not attached to the 4 and the 9. Okay, so those are different things. So what I'm going to do here, I'm going to take the 4 and the 9, and I'm going to go ahead and multiply those together. And then we've also got z to the 5th times z to the negative 12th. Okay, so I'm going to split those two things up and go ahead and multiply them out like so. So we have 4 times 9 is 36. And we're left with z to the 5th plus negative 12, or just minus 12. And that will give us 36z to the negative 7th. Okay, now if you remember that negative exponent, we talked about it in 7.1, I believe it was, that we can go ahead and move that to the denominator. So if we were going to simplify this completely, we would get 36 over z to the 7th. Okay, and that is it for that problem there. Okay, so really just make sure when we have coefficients rather than the numbers being bases, you can go ahead and multiply those out like we did here. All right, go ahead and try out got it problems A and also got it problem C. Okay, and then we will go ahead and move on again after that. Okay, so before we go on too much further, it's important that we talk about scientific notation. So at the top of page 427, they talk a little bit about scientific notation. Okay, the main things that we need to see are in this little paragraph right here. Okay, so the goal is to write numbers that are either really, really big or really, really small in a way that is just more convenient and easier to write them. Okay, so the form for scientific notation is a times 10 to the power of b. Okay, a needs to be between 1 and 10. All right, so it's got to be less than or equal to 1, and it's got to be less than 10. Okay. A good example of this would be the one that they give you actually is a pretty good example, so we'll just stick with it. So we have 256,000. Okay. Right now, my decimal point is right here. Okay. If we were to completely write out the number, that's kind of where we would be looking at if we included the tenths place. Okay. So recognizing that our decimal is right here, we now want to move the decimal so that it gives us a number that is between 1 and 10. Okay, so I'm going to move it 1, 2, 3, 4, 5 times. Okay, it's important that we know how many times we've moved the decimal. Okay, and if we put it right here, now we've got a number that's between 1 and 10. Okay, so now I'm going to write 2.56. 6 is my last digit. That isn't 0, so that's where I can stop writing there. Okay, and then times 10 to whatever power that I just moved it by. Okay, so that would be the 5th power for this one. Okay, now if we aren't sure, sometimes we can have a negative exponent here as well. Okay, a negative exponent would be we moved it this direction. All right, if we aren't sure if this should be positive or negative, okay, I'm going to go ahead and write that down for you. Okay, so I wrote here, you need a positive exponent if the standard notation, which is just the notation we pretty much have always used for numbers, if that standard notation of the number is greater than 1, okay, that's when you're going to have a positive exponent. If it's a negative exponent, if the number is less than 1, that's when you're going to have a negative exponent. Okay, so an example of this would be the number like 0.0005. Okay, an example of a positive exponent would be like 1 million. Okay, so that is what we were looking for, or we are looking for, I guess, when we look at scientific notation. All right, so we'll go ahead and get back into what they were talking about in the book. Just keep this in mind, especially for this next part. This is where it's going to come in. Okay, so the book gives us a pretty hefty first problem for scientific notation. So we're actually not going to use it. We're going to use one that's different from that. Okay, so I'm just going to come up with one real quick. If we do 4 times 10 to the 8th power times, let's do 12 times 10 to the 5th power. Okay, so we're going to use a few of the different concepts that we've already talked about in this video. Okay, the first thing is we're going to take out the 4 and the 12. That's kind of, we talked about it earlier, where you don't, or you can kind of simplify them or solve for them if they don't have the exponent attached directly to them. So the 4 and the 12, if we go ahead and do that, okay, that should give us 48. Okay, and then we've got our exponents on the 10. Okay, so we have 10 to the 8th times 10 to the 5th left over. Okay, and this is where we look at what we were talking about earlier on with multiplying the bases. with multiplying exponents that have the same base. Okay, we just add those exponents. So that will give us 48 times 10 to the 13th power. Okay, now this is not scientific notation. Okay, the reason is this number is not between 1 and 10, which means we need to make an adjustment to it. Okay, so right now my decimal is right here. What I'm going to do is I'm going to move it one spot over. Okay, that's going to give me 4.8. And then when I do that, I've also got to add 1 to my exponent on the 10, right? That lets us know that we need to move it, when we move it back the other way to get to standard notation, we've got to move one more time than we did for 48, okay? So that means our scientific notation should be 4.8 times 10 to the 14th power. And that's it for that problem, okay? So I know that's a lot of information there, but we will look at this a little bit further later on, particularly when we are in class. All right, so our last thing here is simplifying expressions that have rational exponents, okay? Now, when we see rational exponents, if you go to page 427 again, okay, it tells us here that fractional exponents are just called rational exponents. Okay, so whenever you see rational exponents, that just means it's an exponent that has a fraction in it. Okay, so rational exponents, they're really just like finding roots. Okay, so if we had 36 to the 1/2 power, that's the same thing as if we did the square root of 36. All right, so that would give us 6. Okay, so that is what we are looking at with these problems. Okay, so on problem 4, it says 81 to the 1/4 power. Okay, I am going to, and this isn't how the book does it, right? The book is just saying find the number that when multiplied by itself 4 times gives 81. Okay, you can do either one. You can do what they do there, just find that number, or you can look at it the same way that I'm looking at it, which is like this. Okay, I'm going to use the 4th root of 81. Okay, and I actually look at it the same way that the book does, where I'm just thinking, okay, 3 times 3 times 3 times 3 is 81. Okay, but I prefer to write it this way just because for me it makes more sense to do it that way. But again, that's totally up to you. So I know that that's going to be 3 times 3 times 3 times 3. So really, we just need the 1, 3. Okay. So yeah, that's really it for that problem. Not a whole lot to it. I want you to go ahead and try out Got It problems A and B on this page. I'll erase that and redo it so you can see what number it is. And yeah, I think that is going to actually be it for this video lesson. So I will see you guys back in class.